We are Petra Gartzen from Cambashi and Joe Walsh from Intrinsim, and we're going to share with you our insights on the CAE market as well as the overall industrial software market and the current environment that we find ourselves in. To start with a quick introduction on who Cambashi is, we have been tracking the technical software industry in great detail since 1984, and our data goes back a very long time, almost from the beginnings of the CAD market. Our name is formed of the word CAM from Cambridge, because that's where we're based, and the Japanese for bridge, which is Bashi. The data sets that we're using today come from our product country industry observatory, where we cover software for architectural design, construction, operation, CAM, PLM, you name it. We cover it in detail across most of the countries in the world, as well as 112 industries. And our data tends to cover 8 to 9 years in time. We will also look at the Employment Observatory, which tracks the number of people that work in a specific profession, in an industry, in a country, which is very important when you move to a subscription model and you want to size the opportunity in terms of seats. And our CAE Observatory is at the moment the only source of information available that covers the CAE market in this detail, where we have 480 vendors, where we track them across 14 capabilities, 11 industries and 8 applications. Our talk today will really look initially at the environment that we currently find ourselves in, and then look at how big is the actual market potential. And then we look at what are the opportunities for engineering simulation in this very uncertain world we find ourselves in. And then look at the growth opportunities for software, and as usual, finish off with some key takeaways. So to start, at the moment, our industry is experiencing, or the whole world, not just our industry, tremendous turmoil brought about by 2 massive storms. One is COVID-19 and everything that this has brought about, as well as climate change, which has really become an issue over the last 2 years, and the realization of what is happening to the world right now. And when you look at it, it touches every aspect of our lives. With COVID, we are changing the way we work. And this has major implications on how many people will ever go back into the office. This will require a major redesign of office facilities, and to make workers feel safe in the office environment, you also need to model how the airflow works in an office, in a building. It requires major workplace redesign, which again is all offering opportunities for technical software. But we're also seeing things brought about, which is labor shortage, that is bringing about shortage, of course, in materials, as well as transportation, and panic buying, which is again bringing about shortages in product, messing up the supply chains. We have people sick in factories. So again, things that should be produced probably take longer. All of these kind of issues are currently affecting our lives in a way that was never anticipated. And then in addition to all of this, you also have the issue of climate change, which and we've seen massive weather events even this year, terrible storms in Germany, in the US, in Asia, as well as fires, etc. And all of these disrupt our very, very distributed supply chains and cause, again, shortages. But it also, again, means opportunity. For example, when we look at buildings, we will now need to design or redesign buildings to make them environmentally safe. And that, again, requires investment in simulation technology as well as design software. The whole infrastructure for these electric vehicles and new sources of energy, all of that will need to be reimagined and redesigned. Also, in terms of what's happening with finance and investment, more and more people, when they invest in companies that manufacture anything, will want to look at, are these companies that I'm buying from or investing in, are they environmentally sound? Do they have the right measures in place to not pollute the planet anymore, any further? And all these kind of aspects bring about massive change in our industry, in the whole way we work, with whom we work. The entire supply chain will need to be reimagined almost in order to accommodate the climate change that's happening and also to improve the situation. But outside of these massive events, we also have some self-inflicted issues that are currently affecting the entire manufacturing and construction industry. The UK has shot itself in the foot with Brexit, and that is currently causing empty shelves in supermarkets. You try and find Parmesan at the moment, very difficult. Another major supply chain issue was introduced when a ship, the Ever Given, got stuck in the Suez Canal, and that meant hundreds of ships could not go to either side of the Suez Canal for over a week. And all these ships were transporting vital components for the manufacturing and building industry, and all of that caused massive delays that we're still feeling today. Then you have the US-China trade conflict, which again is causing issues. That meant chip production was moved to Taiwan and to Korea, but they were already at capacity, and then Taiwan suffered an environmental impact as well, and all of this caused massive shortage of chips in the industry. And that resulted in the fact that Ford, for example, could not finish all of its cars, and they piled up in the car park. So it really means we will have to look at how we work with supply chains, perhaps even shorten supply chains in the future, or revisit the way our supply chains currently work, because all of this will have an impact on our industry. And now we're looking at the opportunity for software. And it is immense, really, and not penetrated to all its extent. At the moment, most of the engineering software is really focusing on the top tier, where we say there are worldwide around 10 million architects and designers. And this is also where our industry started. And then we moved into the engineers and technicians, of which there are like 44 million worldwide. And these are addressed by the whole PLM, CAM, as well as CAD side of technology. But in addition to this, and brought about by digital transformation, you have another 350 million or so additional people who all need to be brought into the digital transformation, the digital working environment, because they may not design files, but they will need to interact with the design files that are created or the engineering data that's created and feeds back into this. And there is tremendous opportunities for technology to integrate the machine operators as well as the managers and supervisors into the digital manufacturing, digital building environment. And they may not be using the high-end software. They will be accessing the information via a mobile device, but it will require them to be able to access and interact with the models that are being generated by the top tier of the pyramid. And also digital transformation that is being accelerated by the two events we discussed earlier is obviously also accelerating everything connected, the whole industrial IoT world, which means everything that can be connected should be connected and is currently, because everyone has been working remotely, and that has brought about much more knowledge on how that works, but also improvements in the technology to enable this. And especially when we look at the growth projections for things like a connected building, environmental impact brings about that information has to be communicated back and forth to make sure that the building is built to the right specs and is continuing to operate to the right specs. And the only way you can do that is by integrating it into a digital chain. And obviously connected production, that's already generate a lot of revenue and is the biggest in terms of revenue and the most advanced, because this is where really digital twins started. And again, that is accelerating. And when we look at the growth rates going forward as well, it's we expect that to grow even more, especially with all the experience that we've gained through the remote working environment. And now we're looking at how all of this is impacting simulation and simulation technology.
So the market storms that Petra has been telling us about are actually accelerating what we refer to as engineering simulation storms, which are related to the changing role or the increasing role of CAE in simulation already. So COVID-19 that storm is clearly impacting a move to cloud and SaaS. The barriers to cloud came tumbling down as virtual work became the norm. There was no other option. We had to figure out how to do some things in the cloud. And the whole discussions about accountability and security, although they still exist in some cases, a lot of the hesitancy just went away because it was the only option. And the benefits of flexible resources became much clearer because we needed to become much more flexible. So this was already something that was occurring in the engineering simulation space. It just got accelerated by COVID-19, giving us no choice but to figure out how to work remotely. Similar to that, virtual prototyping. There already was a strong move to do virtual prototyping rather than physical prototyping. However, with COVID-19, with the inability to actually have people working together physically, the physical prototyping the testing often became totally prohibitive, and it had to be only as needed. And so that significantly accelerated the transition to virtual prototyping. Now we're going to take a look at climate change and how that impacted some of the engineering simulation storms that were already occurring. The first thing is sustainability. There was already active effort in the engineering simulation community about sustainability, but now it's actually increased the simulation of environmental impact. The climate change is causing a higher priority on understanding the impact of that something has on the environment and the impact that the environment has on an object. And also it's requiring people to think about infrastructure assessments that they would not have been doing at this point in time. In addition to that, it's also caused autonomous everything, the connected smart everything, smart electric cars, smart everything, interconnected data, and that launches a need for a massive amount of simulation to understand behavior and decision making. So there's also, in addition to that, several other storms that were already going on in the engineering simulation space. This includes things like Industry 4.0, which was already gaining ground about smart interconnected manufacturing, driving manufacturing process simulation, the digital twin and digital transformation that's going on in the world. And this drives a huge need for engineering simulation models across the entire product and process lifecycle. In addition to that, there's increasing system complexity. Everything is becoming inordinately more complex than it was not 10 years ago, not 5 years ago, more complex than it was last year. And next year, it's going to be more complex than it was 6 months ago. The rate at which complexity is increasing rapidly and is geometric in its rate of increase. So that drives a need for model-based systems engineering, and it also drives model-based simulations, and it also drives a need for integration of these system simulations with the detailed CAE simulations, and which is crossing two different worlds. We're also seeing generative design enabling performance-driven design from the start, and the ability to explore a much broader set of design options and to explore new manufacturing options like additive manufacturing. And we're seeing the increase in the use of artificial intelligence and machine learning related to engineering simulation. There was a great deal of discussion about this for several years, but within the last few years, there's been a really much clearer collaboration on how that should be used and how simulation can benefit for efficiency and cohesion of data and complexity, and how it can leverage artificial intelligence and machine learning. And I think in this conference, you're going to learn more from Hexagon about the efforts they're putting in there. But the reality is it's becoming much clearer on how the two can integrate together. And that clarity has been within the last year or so. And that's all of these different things has led to an increasing strategic awareness that simulation is key to competitiveness. And it's also bringing about a host of lots of new application areas, such as biomedical virtual populations. The idea that we can't do clinical tests on a new medical device or drug because it's just prohibitively expensive. And if something goes wrong, that expense is just incalculable. Where if we can handle that with a virtual population and do the whole thing with it as a biomedical simulation using physics, it really changes the game. And there's other game-changing items. That's just one interesting example. I think manufacturing processes and interconnected manufacturing processes are another game-changing opportunity. So all of these things that are happening, going from the acceleration of the storms, the engineering storms, from the major overall market storms to all the previously existing engineering simulation storms, are leading to a perfect combination or perfect storm for simulation revolution. So what is a simulation revolution? The simulation revolution is about making engineering simulation widely available and appropriate to support improved decision-making throughout the entire life cycle of engineered products and processes. And it is alive and well and coming to a location near you. That should result in strong expected market growth for engineering simulation through 2025 and beyond. So let's take a look at some of the CAE Observatory data to back that up. It's expected that CAE software revenue will double over 7 years. And we did have a smaller growth in 2020 and 2019 because of COVID, but look at the rebound that we're expecting in 2021 and 2022, and then a steady growth with actually growth increasing in 2025. Usually when a market grows that way, the growth rates slow down because you're trying to grow a much bigger thing, but we're seeing that the growth rates are actually going to increase. This is because of those the perfect storm for a simulation revolution. If we look at the performance by industry, there's new working processes that are speeding up digital transformation in AEC. And here's an interesting insight that subscription models are shielding the vendor revenues in the short term, which is why we see more revenue in 2025. As vendors shift to subscription models, it takes a while for that subscription model to actually catch up and produce more sustainable revenue. Looking at this, we see the only industry that declined in 2020 was automotive. Everything else actually still increased. And we see that the public sector, although it was smaller, had the largest increase, in AEC and high tech also had very high increases in growth. We can look at this opportunity by industry another way, which is looking at what was the growth rate from 2017 to 2021, and what's the growth rate from 2021 to 2025. And here we see that the automotive is experiencing a bounce back from 2020. And by 2025, it's expected to be 25% of the CAE software revenue. High tech is the second largest consumer, or will be the second largest consumer of CAE software. Most people would have expected that to be aerospace and defense, but actually there's a lot more going on in that area. Other areas of huge growth are process and pharma, so that we can see that one. And we see the aerospace and defense is actually still growing rapidly. We can look at this by capability and see where the growth is. So computational structural mechanics and computational CFD, fluid dynamics, are 45% of the CAE software revenue. And they're going to grow $2 billion between 2021 and 2025. So even though they're large, their growth rates are sustained. We are seeing failure modes and simulation data management growth rates increasing, manufacturing process growth rates and multi-body dynamics growth rates increasing. And plastics growth rate is decreasing, but it's decreasing from over 15% to still over 12%. So it's still one of the fastest growing areas, but its rate is actually decreasing. So now I want to talk about some of the key takeaways from looking at the storms, looking at what's actually happening in the CAE market. There's untapped potential outside traditional design functions. With access to higher end applications and data access for managers and supervisors, and access to an interaction with information via mobile devices for a large number of skilled tradespeople. There's been a talk about how simulation can be used in different areas and beyond the engineers for a long time. There's actually significant effort going on in quoting and configuration and making sure systems are right. This is actually starting to really happen. Companies like GCAN and others are very heavy into this. CAE software revenue is expected to more than double over 7 years. And the major vendors are expanding their portfolio with niche vendors, and sometimes that's collaboration, sometimes that's acquisitions. And there's a further shift to recurring revenue streams and the cloud, and new technologies are emerging and new applications expanding the opportunities. The simulation revolution is alive and well and coming to a location near you. Thank you. Any questions?